Welcome to the StormSurf Video Surf Forecast for the week starting Sunday, June 4th. Looking at significant wave heights for the South Pacific Ocean, we see a rather placid pattern in play. No seas of interest are occurring. Let's get into the details. As usual, we'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they do form, help direct their track. We're looking for a trough. That is a dip in the jet pushing to the north, sort of like that there, though that really isn't a good example of a trough. There is not enough wind pushing to the north, and the gap or the push to the north does not cover sufficient area. So basically what we have here is a split zonal jet stream flow. That is the northern branch of the jet running at about 26 degrees south across the Pacific, a little bit of a ridge pushing south there, and the southern branch down around 62 south, running generally west to east, flat, pretty much. No dips, no troughs, no nothing. So this pattern is not supportive of gale development. If anything, it just sort of supports high pressure in between the two branches of the jet. Let's roll this out, see what happens in the future. We get into Tuesday or so, and it almost looks like a little patch of energy here tries to develop under Tasmania. What is that? 140 knot winds, and that's about in the speed range you're looking for. And it kind of pushes to the north a little bit here under New Zealand, but still just doesn't push cleanly to the north, doesn't really open up. Nothing, and if anything, then it starts pushing south. That would turn into a ridge, and just not anything that really looks like it's supportive of gale development. What you want is this, just like here now, you get into Thursday night, push to the north. That would get you a clockwise flow aloft. And then also down at the surface, that's the hallmark of low pressure. And of course, low pressure generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, produce swell. And swell, when it hits your beach, creates surf. So sort of something, again, tries to organize here south of Tasmania on Friday. Winds in the, what is that, 140 or so knot range. But again, just not a good, clean-looking trough. Again, another patch on Saturday or so. And there we go. That almost looks like a trough there, but not super well-defined. 180 hours out, yes, finally a trough. And there's a ridge here. A bit of a trough starting to organize outside the California swell window here, targeting maybe south, south Chile or so. But again, you really want a little bit more wind energy pushing off to the northeast. So generally speaking, jet stream doesn't look super supportive. And that has sort of been the pattern of late. That sort of also ties into what's going on with the MJO, which is kind of lackadaisical, and the whole El Nino La Nina thing, which is sort of in no man's land. There just doesn't appear to be a lot of energy, at least looking at this chart, in the upper atmosphere to support storm development. So next we take a look down at the surface. Surface level pressure, surface level winds. We're looking, of course, for fetch and deep low pressure. And as you can see, just glancing, you want to see at least 35 knot winds, preferably 40 or 45. No signs of that anywhere. Pretty much the jet stream, again, running in the southern branch, let's say roughly 62 south along this line. And you see, yes, sort of a trail of fetch, but nothing of any interest. We'll just roll this out. You get a little bit of fetch here, 35 knot winds on Monday, but all pushing south over Arctic ice. Another little guy here south of New Zealand on Monday, all fetch aimed south. Then we get 45, almost 50 knot winds here on Tuesday, but the belief is that crashes to the south and is actually over the ice line. I'm not sure where ice line is, but let's say roughly around 65. We'll know in a few minutes here. Cutoff low tries to develop Wednesday in the far southeast Pacific, but it pretty much falls apart rather quickly. Now, a more interesting system develops Wednesday, we'll just say halfway between New Zealand and Tasmania, Tasman Sea here. 40 knot winds. Let's actually roll back and take a look. Now, notice it's actually pointing to the south, and the Great Circle tracks are going up this way, so not too interesting yet. But then you get into about Thursday morning, 40 knot winds pushing off to the east, a little bit of energy probably radiating up the Great Circle tracks back in this part. Now we're down to 35 knot winds midday Thursday, and that all fades out. So still nothing that's really getting our attention. Then we get into Saturday morning, a little patch of 50 knot winds, same area, and then building to 55 knots, first 12Z on Saturday. This actually looks semi-interesting, but it's 138 hours out. Building 50 knot winds into Saturday and aimed well to the northeast on Saturday night. This actually looks legitimate at this moment, but it's 150 hours out. And then it too fades and falls to the south. Some more fetch develops here, but this is certainly over Antarctic ice at 174 hours out, and that's the end of it. At least there is some hope in the long-term picture. Let's go take a look at the wave model charts. Here we go, significant wave heights for the South Pacific Ocean. Just roll this out, nothing going on. We're into Monday. That first little gale under New Zealand on Tuesday, it crashes south. Here's the ice line we were talking about. 65, 64 south, maybe down to about 66 or 67 south. No hope there. First system starts developing under New Zealand on Wednesday. 32-foot seas and kind of almost falling southeast and fading pretty quick. Probably not a whole lot, if anything, from that relative to our forecast area. Then we get into Saturday, stronger system, 33-foot seas building to 37 feet, 38 feet midday Saturday. Looking pretty good. Certainly some swell should result from that, but the issue is it's way off. The models are not accurate this far out. This system here with 38-foot seas, 37-foot seas, it's outside the California swell window. The California swell window cuts off about 117 west. Let's just go back. No, nothing really in the window there. And so this is only a swell producer relative to Chile and maybe Peru, and that was the end of the run. So all the hope really lingers in the far-off future, and the margin for error on models far out, systems far out in the model is pretty high. Now, that's not to say there isn't swell in the water. There currently is. Small swell hitting California. It formed in the southeast Pacific, bypassed Hawaii. That swell is peaking, probably peaked this morning in California, is on its way down. There is one smaller system that developed behind that. This is it here. It started Monday a week ago, peaked out about Tuesday morning with 27-foot seas, a little patch of 28-foot seas again in the southeastern Pacific. Small swell from this should arrive in California on Tuesday of this week, but more energy, of course, Central America down into Peru. And then after that, things go pretty much flat from the southern hemi perspective. No swell until perhaps one of those systems forms. We saw that, better part of 5 or 6 days out on the model, and then another 8+ days travel time if the swell forms. So we're talking better part of 2 weeks out. So whatever swell there's going to be is hitting now and probably will continue into about Wednesday or Thursday relative to California, and then things go to sleep for a while, so get what you can. Relative to the North Pacific, as of Saturday, a day ago, a small gale developed here, we'll say in the northwestern Gulf. By small, we're talking 14-foot seas, building to 16 feet Saturday night, and in the 15-foot range into Sunday morning. And those seas are to regenerate a little bit further to the north come this evening. 16-foot seas falling to the 15-foot range into Monday morning and then gone. We'll just roll this out so you can see there's nothing else of any real interest. I think I spoke too soon. Friday now, this run of the models, suggesting something in the Gulf. Seems hard to believe. 23-foot seas seems like a major reach given the time of year. If that were to materialize, some small swell in the 14-second period range would result. We're not going to believe any of that at this early point in time. Instead, we'll go with what we saw, the 15-foot seas. That's good for like 10 or 11-second period wind swells somewhere in California. Probably midweek, and in the 3 or maybe 4 foot range at 11 seconds. Let's say 4.5 foot surf at best. But really, it's wind swell along the California coast. In fact, let's take a look at that real quick. So here we go. Surface level pressure, surface level winds focused on the northeast Pacific. Here's the low pressure system we were talking about earlier that's generating 15-foot seas, 30 knot winds there in the Gulf. But we're just focusing here off of California. Currently 20 to 25 knot winds pushing down the north and central California coast. That due to high pressure here pushing inland. Heat low pressure inland creates a pressure gradient. That is tightness of isobars between the low inland, the high over the ocean generates the tighter the isobars are, the stronger the wind is, generates north wind, and that generates local junky wind swell. That's supposed to go on Monday. Now we're into Tuesday morning. The gradient starts fading. Now here's the other interesting thing. Notice low pressure in the Gulf of Alaska, and this front here is actually supposed to push right up to the California coast. That will certainly cut off any winds. If anything, we might end up with south winds come Wednesday night over Cape Mendocino, maybe down to, we'll say Point Reyes, and even that's a bit of a reach. And that front blows through pretty quick on Thursday. Then we just have a light pressure pattern. Notice high pressure, 1026 millibars north of Hawaii, starts ridging to the east on Friday. But there's also, here's that new low pressure system we were talking about on Saturday here in the Gulf of Alaska. The high pressure noses into California. Again, you get the gradient forming, north winds building, but notice it's all focused right here on the Point Conception area. Maybe that's wind swell for Southern California, but nothing for North and most of Central California for that matter, until you get into, about Monday or so. There's the end of the run, and then we get the fetch builds more over Central and North California and providing potential for wind swell down into Central California, but not a whole lot going on. So the short of it, what do we have? Wind swell locally for the early to mid part of the week. Some of it local, some of it from the Gulf of Alaska. Lingering bits of southern hemi swell and a new pulse on Tuesday. Probably get you into about Thursday with some rideable southern hemi swell. And then we go back to wind swell for late in the weekend or early next week. But pretty much a typical light swell summertime swell pattern. All right, let's take a look long term. Let's find out what's going on with the MJO. Of course, the Madden-Julian Oscillation helps fuel the jet stream in winter months and summer months. When in the active phase of the MJO, of course, feeds energy into the jet, which then in turn helps support storm development. Beyond that, then, let's take a look at the El Nino Southern Oscillation. ENSO, see what it's doing. We're out of La Nina. Are we moving to El Nino, or are we just sort of hanging somewhere in the middle? We'll find out. So we start off looking for signs of either the active or the inactive phase of the MJO. The best way to tell is by looking at winds on the equator in what we call the Kelvin wave generation area. The area from 170 west to about 135 east. There's New Guinea there. There's the date line. This is the equator, 5 degrees north and south of the equator. Actual winds across the entire Pacific Ocean on the equator, you can see, are from the east and pretty brisk, especially brisk here over in the far eastern Pacific. This is from the TAO buoy array, actual buoys lined up across the equator in various locations, used specifically for monitoring El Nino. We look at anomalies, differences in wind speed for this time of year, and generally the pattern suggests a normal pattern for this time of year, except here in the far East Pacific, and we have east anomalies. So that would enhance upwelling off of South America and Central America. Another chart here, 850 millibar wind anomalies. This is up about 4,000 feet, but sometimes it's a pretty good proxy for what's going on down at the surface. Kelvin wave generation area. Draw a little box, 5 degrees north and south of the equator, right in this area here. There's, of course, Australia, Philippines here, just to give you some bearings, South America here. It's this area right in here. We see east wind anomalies. That was on May 29th. and just sort of scanning quickly down here. We see those east anomalies are backing off, and we're getting into sort of a east anomalies north, west anomalies south, sort of a mixed pattern. We'll just call it basically neutral as of June 2nd, and that is what has been expected. So we're moving from, this would be the inactive phase of the MJO, moving to a neutral MJO pattern. The forecast here, again, 850 millibar winds up about 4,000 feet, and the Kelvin wave generation area, this is the whole globe on one chart, and with time going back as far as May 5th. Kelvin wave generation area, we'll say right from about here to here. The blues and purples are eastern anomalies, so you can clearly see we were in the inactive phase of the MJO. Of course, that doesn't support storm development in the southern hemisphere from pretty much all of May. Here's where we are right now. The forecast per the GFS model suggests moving towards a pretty much neutral, maybe some light easterly anomalies for the next week, but there's also some westerly anomalies on the very far western side of the Kelvin wave generation area. Let's just say a neutral pattern, neither the inactive or the active phase of the MJO. So neither that would not suppress nor support storm development. Looking at forecast models for the MJO, this is outgoing long wave radiation. The active phase of the MJO pretty much supports stormy weather, cloud cover, rain in the West Pacific. Again, limited to the Kelvin wave generation area right in here. The blues are negative outgoing long wave radiation, meaning cloud cover, meaning the active phase of the MJO. So per this, the statistical model, the active phase of the MJO is to move over the Kelvin wave generation area over the next 2 weeks. But looking at the GEFS model, which was also the model we saw in some of the previous charts, it suggests the active phase is to die out. Then the inactive phase, these yellows, more reflection off the ocean surface, less clouds, meaning high pressure. So the inactive phase of the MJO, perhaps setting up 2 weeks out. So the models are decidedly in opposite, going in opposite directions. Typically when you get this, that sort of means a neutral pattern. It doesn't go one way or the other. They sort of blend in the long run, and you end up with nothing. Phase diagram charts, another way of looking at the MJO, assume you're looking down here. Assume this is the North Pole of our planet, and the MJO moves from west to east, from the Indian Ocean to the Maritime Continent, over the West Pacific, under the U.S., across the Atlantic, on top of Africa, back to the Indian Ocean. The heavy dot is where the active phase of the MJO is. This circle, if the dot is on or inside the circle, the active phase of the MJO is considered to be very weak, and so it is over the Maritime Continent, so say like Bali, that sort of area, very weak, and over the green line over the next 2 weeks, the MJO is forecast to basically crash, be indiscernible, and just not a player, per the ECMF model. Per the GEFS model, basically the same thing, or if anything, it's supposed to loop back and maybe redevelop in the Indian Ocean. Either way, either of these scenarios is not supportive of storm development in the West Pacific for the next 2 weeks. And yet some more info. We're just trying to tease out what the MJO is doing, though it seems pretty abundantly clear what's going on. But anyway, upper level model, again, greens are the areas supportive of precipitation and therefore the active phase of the MJO. This is a 40-day model. Suggests there's maybe some very weak active phase trying to move into the West Pacific, and through about June 24th, it's to make its way into Central America and fade. And then an equally weak and gutless inactive phase of the MJO is to develop in the West Pacific on, let's say, June 19th, make its way across the Pacific into July 9th or so, and then a dead neutral pattern after that. All this sort of smells that the MJO is weak, the ENSO signal is weak, the jet stream is weak, and there's just nothing driving the atmosphere to just like unleash a storm or anything. There just isn't much latent energy in the atmosphere. And of course, our favorite model, the CFS model, this is 850 millibar winds. Again, winds up about 40,000 feet. The Kelvin wave generation area is right in here. The forecast is forward. The hindcast is down here. We'll overlay the MJO. The dotted contour is the inactive phase, the MJO. So we see the MJO was strong. The inactive phase was strong here over the Kelvin wave generation area with blue meaning easterly anomalies. Most of May. That's consistent with what we've seen in the other models. And that the inactive phase is fading over the Kelvin wave generation area and should be gone in about 4 or 5 days. But notice this. It's supposed to be the active phase of the MJO, very weak, and it tries to make it to the date line and fades by June 20th. But supposedly some westerly anomalies are to develop. That might help push a little bit of storm development. And then it's not till we get into the first week of July that the real active phase of the MJO develops, with westerly anomalies developing over the Kelvin wave generation area. Notice these easterly anomalies, though. Here we go. Oh, you can't quite see it. Well, maybe we can do it this way. Just pull that in just a little bit. There you go. Okay, there's the date line right there. So these easterly anomalies, for the most part, are not in the Kelvin wave generation area. The westerly anomalies are. That's what counts. That's what fuels the jet stream, both for the South and the North Pacific. So supposedly, light to modest westerly anomalies in the Kelvin wave generation area once we get into July. But the models have been teasing at this for, like we said, every week, for weeks now, and it never materializes. If we can get this blob of westerly anomalies by the end of June, that would be a sign that maybe we're turning the corner. There's still some hangovers in the upper atmosphere from La Nina going on that tends to be suppressing westerly anomalies and enhancing easterly anomalies, and we need to turn the corner. So, the low-pass filter, this shows you the presence of El Nino or La Nina. The dotted contour is La Nina at the most basic hidden levels of the atmosphere, and it is supposed to be gone by, we'll say, June 14th, so basically a week out, just a little bit more. Originally, it was supposed to be in the May 5th, 6th, but it's still hanging on in the atmosphere. It's supposed to be gone then. And notice, then as we move into the August time frame, it's supposed to return a little bit here, but mainly the focus of it is supposed to be over the inland from California, around 110 west, and not over the Kelvin wave generation area like it was here. That'd be a good sign. So that would actually support the idea that westerly anomalies might take root in the Kelvin wave generation area. And as we move into fall, we might have a little bit more energetic flow there, and that would also support the jet stream. That would help support storm development, but nothing marked, nothing particularly noticeable, but maybe just a little bit more than what we've had since last year. Let's take a look into the ocean, see what's going on. We've talked about the MJO, what it's happening, but what's actually going on in the ocean. This is the West Pacific here, East Pacific here. We're at depth down 200 meters. These are the anchor lines on the TAO buoys. The X's are sensors on those anchor lines. They suggest warm water, 29 degrees Celsius in the West Pacific, with some sort of a flow working its way pretty well off to the East Pacific, but nothing remarkable. But certainly, if it was La Nina, you would see this warm water here being even much shallower than it is. If it was El Nino, you'd see a lot warmer water here, and you'd see more of it flowing off to the east. What we have been watching is the 28-degree isotherm right here. It was at 145 west last week. It's backtracked 2 or 3 degrees, but still not doing too bad. Basically, this looks like a pretty much neutral flow. Looking at differences from normal for this time of year, we see a little bit of warming here in the West Pacific, 1 degree. That's not very much at all. If there were some sort of pending El Nino, you would expect to see 3 or 4 or 5 degree anomalies over here. We don't see anything like that. We see some warm anomalies off of Peru here Ecuador at 3 degrees. But there's just the real thing is, there's not a large pool of warm water here. So even if you were to get westerly anomalies, there's not a warm pool of warm water for those westerly anomalies to start pushing to the east to get El Nino going. The expectation is these warm waters here in the east at some point are going to get driven by trades over this way and fade out. And we're not even looking at this cool pool here, but if anything, it's been retrograding. at depth and is not of particular interest at this time. Another view of the same thing suggests a generalized warm, what do we, half degree to a degree or so of warm water moving from the West Pacific to the East Pacific. Little pocket of cooler water there just off of Ecuador, but kind of a homogeneous flow. No particularly warm or particularly cool pools noted. Just a generalized warming flow, just a little bit above normal, basically. Nothing remarkable. Upper ocean heat anomalies, upper 300 meters of the ocean, West Pacific here, East Pacific here. Time, July, a year ago. Cool water, La Nina, in play. That had since faded out over the winter. And then we see what almost looks like a Kelvin wave here, just half-degree anomalies moving from the West Pacific to the East Pacific. Actually formed a bit of a warm pool off of Ecuador here. Upwelling phase of the Kelvin wave cycle, if you want to call it that. And then another thing that it's not really a Kelvin wave, it's too weak, but some warm water migrating east. But notice down below here, hardly any warm water left in the West Pacific. It's almost whatever didn't discharge during the big El Nino of, was that 2014, 2015? Well, whatever was left has discharged now. And the thought is it's even possible that another La Nina could come a year out. But for now, it just sort of looks like this very homogenized, lukewarm pattern over the entire Pacific Ocean. Next, let's take a look what's going on at the surface. We've looked subsurface. We've looked at all the models talking about the MJO. What's happening? What we see is upwelling along the coast of Peru and Ecuador, just off here. This has been going on for about a week and a half, 2 weeks. Not significant upwelling, but it much larger, cool footprint than was here 2-3 weeks ago. There was actually cooking warm water off of here about a month, 2 months ago. That has faded now. But notice off of South America along the equator, a generalized warming pattern, maybe half a degree or so, something like that, over the entire Pacific, other than immediately off the coast here. And now normally what happens is you get canonically, warm water, very warm water here gets caught by the trades. Notice there's normally high pressure here that pushes up along the coast, takes the warm water here, pushes it over the Galapagos, and then off along the equator into the Nino 3.4 region, which is right in here. This is the classic area for monitoring El Nino. Right now we see marginally warm water, maybe quarter or a third of a degree above normal. But there's no real source for much more warm water being caught by the trades to push into this area. So the expectation is this is probably about as warm as it's going to get out here. And if we were looking for an El Nino to develop this fall or this winter, you would want to see a lot more warm water developing over here. We don't see any of that. The 7-day trend suggests pretty much a neutral pattern along South America. Maybe slightly cooling, but not much. A little bit of warming here off of Ecuador. We're talking just pixels, basically a neutral pattern in this whole area. The only thing that's remarkable is this stretch along here. Warm water off of California, working its way towards the Philippines. That is pretty much a result of weak trades or north winds along the California coast. All it takes is high pressure firing up, getting the north winds going, and this right along here will wipe out and turn neutral. But all this has been consistently in play, perhaps a sign of the PDO, the warm phase of the PDO. Too early to know, though. And the overview, here we go. Again, generalized warming, if you look at the picture, everywhere. Not so much in the Indian Ocean, but all the Pacific along the equator, warmer than normal. The Atlantic, certainly warmer than normal. This bodes well for hurricane development in the Atlantic. There is probably doesn't bode so well in the Pacific, even though there's warmer water here, because there's upward level shear going on here, remnants from La Nina, that would cut the tops off of any developing storms in this area, but not so much in the Atlantic. But it's too early to know just yet. But notice a lot of warm water still going on. A little bit of a puzzle. Is that a climatology issue, or is that a hangover from the big El Nino of 2014-15? or just unknown. We've talked about this in the past, something to watch. And here's that warming pool that we saw that may be tied to the warming phase of the PDO, but who knows? So we've talked about the MJO and what it's doing, which appears to be not a whole lot of anything. We've talked about El Nino, or at least looking at the ocean, trying to get a sense of what's happening from the ocean's perspective, from an El Nino, La Nina perspective. And we see generalized light warming, but nothing more, and no real fuel to support long-term warming. Let's look at the atmosphere above the ocean and see what it's doing. We look at the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Long runs of negative numbers suggest the active phase of the MJO, and if it's long enough, over a long period of time, then it could suggest the development of El Nino. Positive numbers are, of course, the opposite, La Nina, or at least the inactive phase, the MJO. Just looking back the past 20 days or so, we see kind of a mixed bag of slightly positive, slightly negative numbers. We're in a negative 4-day negative run right now, minus 9.84. None of this suggests anything, kind of a neutral pattern. The 30-day running average takes some of the noise out of the numbers, gives you a sense of right now we're plus 0.68, basically dead neutral, neither El Nino or La Nina, neither the inactive or the active phase of the MJO. Looking at the 90-day running average, yeah, we were down to minus 0.4. Today we're at minus 1.63. That says neither El Nino or La Nina, basically neutral. So all data, at least is what we're seeing, looks very much like the atmosphere is just kind of sitting there not doing anything. And then there's the ESPI index. Instead of measuring surface pressure between north of Darwin, Australia, and Tahiti, measures the amount of rainfall mainly in this area. When the index is negative, it means less rainfall than normal here. If you want the active phase, the MJO or El Nino, you'd expect more rainfall here. Current index, minus 1.34. The lowest this has been during La Nina was minus 1.9. And just recently, it started this downward spiral sort of thing, suggesting things are pretty dry right around in here. There's no overt signs of La Nina, but if this is an early indicator, it suggests maybe that we are moving into some sort of weak La Nina, at least neutral, if not drier than normal position right now. We forgot to show this earlier. We're going to do it now. Water temperatures. Again, this is in the Nino 1.2 area, which is basically right off of Central America and South America. That cool patch that we saw on some of the other charts, it's bore out here. Average temperature is about a half a degree below normal, and that just developed since about May 20th or so. And then in the official El Nino monitoring region, water temperatures, we saw it drifting off from South and Central America, are up 0.4 of a degree, 0.452. There we go, and have generally been in that region since the beginning of May or so, and warmer even before then. So almost borderline El Nino, but you know what? The real season for El Nino is not until we get into August, September, October, November. That's when you'd want to see the warm temperatures there. That would feed the jet stream in the fall and winter months into the Gulf of Alaska, and that would feed storm development in the northern hemisphere. We have quite a ways to go. We got to get the whole way through summer, and it seems sort of doubtful these warmer temperatures will hold that long. Here's the forecast from the CFS version 2 model. Nino 3.4 region sea surface temperatures, pretty much the same as what we saw last week. We are in this sort of semi-warm period and have been half a degree above normal. There you go, there's your half a degree. And the forecast is that temperatures, as we get into July and August, should drop off some, still 2 to maybe 0.3 of a degree above normal. Then as we get into the fall, we fall into dead neutral pattern. So that would neither support nor suppress storm development, kind of a normal pattern. But when you see this, what that also means is there's not a lot of energy in the atmosphere one way or the other, which generally means that storm production would tend to be pretty weak in the fall and winter months. So to wrap it up, right now, small southern hemiswell hitting California. Another little pulse expected only into California and down into Central America, South America in the Tuesday time frame, and then fading off into nothingness. Hoping that the models are right, hoping that by about Saturday or so, some storm activity pushes under New Zealand. If that were to happen, though, it would still be 10 days till that swell reached our coast. So we're talking another weekend or more beyond that. So the more likely scenario is wind swell along California. We haven't even seen much that suggests wind swell relative to Hawaii, with trades a little bit below normal and kind of light in the 10-knot range. So wind swell looks like the name of the game for the next probably 10 days after the southern hemiswell dies out. Beyond that, a weak pattern suggested both with MJO and El Nino La Nina, just kind of the atmosphere kind of not doing a whole lot. No clear signs that it's going to budge anytime soon. And not unexpected, the ocean and the atmosphere is in recharge mode after 2 years of El Nino back in 2014, 2015. And we don't have any clear signs of the PDO. We'll be looking for data from the long-term models and we'll update you. But the expectation is pretty much a neutral pattern is in play for now and for the foreseeable future. That's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching.